Uh, before that, Assalamualaikum warahmatullahi wabarakatuh. We are from group 3, and then we have the title of the journal is about the analysis of the impact of using cloud computing system on climate change. So we are 5 person in this group. It can be Faisal, James, Sultan, Shurai, me, and the last is Adli Fitra Kusuma. The next, okay, for the one, it's abstract. It will be presented by my friend.
Okay, I will explain about the abstract. Uh, okay, so the uses of the cloud computing is currently very rapid. With the development of the cloud computing, human work is get easier. Like if you want to use the services of the cloud computing, you can access it very easily nowadays. And however, if you look at the environmental perspective, cloud computing also has an effect. We gather data research from journal, article, and ebooks. The data show the link between the use of the cloud computing and the climate change that is happening in the world. If you may realize that the ozone layers as the factor of the climate change can be depleted due to many factors. One of the factor is the use of the manual computing, which emits a lot of carbon dioxide emission to the large energy requirements. So the cloud computing can be the solution to prevent the climate change because the emission tends to be lower. In addition to that, the green computing can be also used as the solution to prevent climate change based on four components, namely the green design, green use, green disposal, and green strategies and policies. Okay, the next is about the discussion. Kusuma, take over.
Okay, so for the discussion next. Okay, so for the discussion that we discuss about the cloud computing for the impact of the climate change. So the use of cloud computing can impact the large consumption of electrical energy in data centers used to store and manage data. Carbon dioxide emission from the information and communication technology industry are currently estimated to account for 2% of the global emission, contributing to global warming. However, some studies show that with cloud computing methods such as virtual machine or VM migration can be used to improve the energy efficiency of cloud computing and reduce energy consumption. In addition, cloud computing technology also helps optimize the use of electrical energy in servers, minimizing cloud computing downtime effort should therefore be made to reduce the environmental impact of cloud computing usage, such as by increasing energy efficiencies and using greener resources. Next. So the climate change is defined as the long-term increase in the Earth's average surface temperature and the large-scale change in global, regional, and local weather patterns that result from that increase, which is caused by a significant increase in greenhouse gas levels caused by the use of fossil fuels. Human behavior, such as the usage of fossil fuels, which brings to natural gas, oil, and coal, is largely responsible for present climate change. These materials both release greenhouse gas into the Earth's atmosphere. These gases trap heat from the sunshine in the atmosphere, raising the average global temperature. This rise in global temperature is referred to referred to as global warming. Global warming has an impact on local and regional climates. Climate has been changing throughout the Earth's history. This is a slow process that has occurred organically over hundreds of thousands of years. The current rate of human-induced climate change is substantially faster. Next.
All right, next discussion. NASA collected the following climate change statistic. First, the Earth's average surface temperature has increased by 1.18 degrees Celsius over the past 2 centuries. Second, between 1993 and 2019, Greenland lost 279 billion tons of ice per year, and Antarctica lost 148 billion tons of ice per year when ice sheets broke off and eventually melted. Third, since 1969, the temperature of the top 100 meters of the ocean has risen by 0.33 degrees Celsius. Of this is exacerbated by the massive annual depletion of the ozone layer. Next. The current state of the ozone layer. Stratospheric ozone is depleted in both hemispheres. However, this phenomenon is more pronounced in the southern hemisphere, Antarctica, than in the northern hemisphere, Arctic. As soon as temperature drop below -78 Celsius, polar stratospheric clouds tend to form, increasing ozone depletion. In Antarctica, the long presence of low temperature in the stratosphere stimulates stratospheric formation, whereas the Arctic is characterized by high annual variability in weather. In general, the ozone hole is defined as the region where the ozone column level is below 220 Dobsonian units, indicated by thick contour lines in Figure 1 and shown in blue. It's only found in the southern hemisphere. In September 2000. The largest historical ozone hole extent occurred at 28.4 million km. This area is more than 6 times the size of the AU. Next. In 2000, the ozone hole reached its widest extent since 1879 and has not increased for several years. This is likely due to passing out of ozone depleting substance under the Montreal Protocol. Since 2001, ODS emissions have been curtailed. The ozone layer has shown signs of recovery, and the interannual variation in magnitude is largely dependent on stratospheric temperature, with rising temperatures shrinking the ozone hole as in 2019. However, this cannot be directly attributed to anthropogenic climate change, as greenhouse gases generally have a cooling effect in the stratosphere. While they contribute to global warming in the troposphere, except in polar regions, this stratospheric cooling has a positive effect on ozone recovery. Here, temperatures are so cold that increased formation of polar stratospheric clouds could accelerate ozone depletion. The ozone hole can be periodically affected by volcanic eruptions and wildfires, increasing stratospheric particulate levels and thereby destroying ozone. This partly explains the occasional year in which the ozone hole is relatively large, such as 2015. It's 27.9 million. Next.
Okay, after that, we continue talk about the discussion. The maximum area of the southern hemisphere ozone hole this year was at 24.5 million square kilometer as of September 26. Okay, similar to the 2021 ozone hole is about 24.8 million square kilometer. Copernicus atmospheric monitoring service research say the 2022 ozone hole is similar in size and duration to the 2021 and 2020. So the ozone hole reflecting a strong and long-lasting polar vortex at the time. Oh, so the size of the 2022 will be larger than the average of the last 5 and 10 years before. So the value of the larger than the average is about the 21.3 million kilometer square and then 21.9 million kilometer square. Ozone depletion is typically much lower in the northern hemisphere compared to the southern hemisphere. However, in the Arctic in 2020 ozone probe measurement show that the ozone layer is being depleted due to instantly severe and prolonged cold water in the stratosphere. So the 2019 ozone hole was a very small, very small and short-lived, mainly due to the unusual weather conditions, especially in August and September in 2019. Unusually high temperatures were seen at altitudes of 20 until 30 kilometers above the Antarctic. Freezing ice clouds that are trap ozone depleting molecules that normally cause ozone depletion when the release of the southern hemisphere in spring. Stop forming overall stopping ozone depletion remains very fragile, and scientific evidence suggests that further steps are needed to reduce the pressure on the ozone layer caused by the ozone depleting substance, or we can say the ODAs. Next. Before that, we discussed about the ozone. So we have the solution to climate change. It's about the green computing as a solution to climate change. Simple solution to prevent this energy problem is to save energy and efficiency. Maximum energy savings will be realized if you understand the concept of the energy management and have the support and participation of all parties, starting from the campus, university, environment by implementation or implementing grid computing. So the grid computing is a policy to reduce the negative impact of the use of technology on survival in the environmental in our life. One of the existing plus of green computing is to solve problems by using environmentally friendly research and using them effectively. So this will be about to reduce the use of research then the threaten the sustainability of the earth and reduce electricity consumption and produce electricity that is a more environmentally friendly with our life is the key to reducing carbon dioxide emissions that have an impact on the environment. So it can be meant about the global warming and climate change. Next. You can see the picture in the left. It's about the green disclosure, green design, strategies and policies, green use. It can be a green computing. So the application of green computing in the campus environment in overcoming the environmental impact due to the use of the cloud computing technology has a major component. The following are the main components in implementing great computing. It's the 4 points. In this PowerPoint, it's about, for the first thing is about the green design. Design energy efficient equipment and environmentally friendly components such as computers, data centers, servers, and the cooling equipment. This can be achieved by adopting new techniques and environmentally friendly materials. The second point is about the green use. The green use is reducing energy consumption on a computer and other information system equipment in an environmentally friendly way. So the third thing it's about the green disposal, updating and reaching old computers and recycling computers, equipment and electronic equipment that are no longer used. Before that, we use the computer, and after that, in green disposal, we recycling a computer equipment. So the last point is about the green strategies and policies. Effective and actionable strategies and policies add a value on the and a focus on short and long term. It's a benefit. So it aligns with a business strategy and practice and is a key component of the green IT. Okay, the third thing it's about the conclusion. It will be presented by my friend.
Okay, in here I will explaining about the conclusion of our journal. From the journal made, it can be concluded, among others, the use of cloud computing is one solution to overcome the problem of climate change. Cases such as increased carbon dioxide emissions caused by industrial communication and information technology contribute to making the Earth's condition worse. The way to overcome the problem of climate change, especially in the field of technology, in the use of cloud computing technology. This technology is able to make carbon dioxide emission lower because compared to creating local servers operated by many computer systems, cloud computing provides a solution using only one central server as the source of operation of all jobs to be created. This makes the community or industry does not need to spend a lot of money because now there is an option to use cloud computing technology. In addition, there is also another solution, namely green computing. The application of green computing can be done in any environment with the use of cloud computing technology. Energy saving can be done by doing green computing method to make electricity consumption and produce more environmentally friendly energy use. This journal successfully explaining the benefit of cloud computing technology for climate change and how to maximize the technology with effective green computing method. Next. Okay, just that from our group. Thank you for your attention. Any question?